All right, this is example 2 for 5-2. So remember our hints said that we wanted to start on the side that was most complicated. So when you look at this one, I know, because I know you guys do not like fractions, that you might think that the side with the fractions is the most complicated, but it really isn't. The left side would be considered more complicated because it has a tangent and a cotangent in it, and that would be something that would make it complicated. If it has just one trig identity or just one trig function on the side, then it's more simple. So this is the side we're going to start on. Now you'll see the example says working with one side, because you'll see in further videos that sometimes you can work from both sides and work until the two meet each other. And actually this one could be done that way, but they want us to work on just one side and make one side look like the other. So, and truth is, there's two ways to do this one. Actually, there's probably more than two, but there's two pretty common ways to do this one, and they're probably equally as easy. So in this case, I'm going to distribute just like we did before, because remember it says if there's anything algebraically that can be done, go ahead and do it. So I've got tangent squared x times 1 is just tangent squared x, plus that would be tangent squared x cotangent squared x. Now, I'm going to leave this one as tangent squared x for just a minute, and I'm going to rewrite cotangent. Oh, sorry, that's supposed to be an x. I'm going to rewrite cotangent as 1 over tangent squared x using my reciprocal identities. So that was my first step. That's my second step. All right, so we have a tangent that's on top and a tangent that's on bottom, so that becomes 1. So now I have tangent squared x plus 1, and that should set off bells in your head. Ding, ding, ding. This is a Pythagorean identity. And so my suggestion is that when you work on this assignment, that you have your identities sitting with you, unless you've got them all memorized. This is a great time to memorize them while you're working on these. But if you don't have them sitting there, you probably need to get them. I could see that tangent squared x plus 1 is actually secant squared x. Well, secant squared x is the same thing as 1 over cosine squared x, which cosine could be rewritten as 1 minus sine squared x, which would make this look just like that. Remember that sine squared x plus cosine squared x, you're going to use this one so much in all different versions of it. So if I subtract sine squared x from both sides, then it gives me cosine squared x, this down here. So that's it. I got one side to equal the other side. So that's what they meant by working with one side. And that's it for this one.